think we're ready to start. So welcome to this new COPSS-NISS leadership webinar. My name is Daniele Durante. I'm an associate professor of statistics in the Department of Decision Sciences at Bocconi University in Milan. And I'm also a member of the 2024 class of the COPSS Leadership Academy. As a little background, COPSS is the Committee of Presidents of Statistical Societies. It is made up of various statistical societies. So ASA, ENAR, WINAR, IMS, the Statistical Society of Canada, along with many friends of society from across the globe. COPSS bestows many awards each year, including the COPSS Leadership Academy, recently renamed to the COPSS Emerging Leader Award. And the purpose of this award is to recognize early career statistical scientists who show evidence of and potential for leadership. And it also provides a mechanism for us to share our vision of leadership within the field. And from this emerges such a webinar series, which is co-organized by COPSS and our wonderful partners at the National Institute of Statistical Sciences. So these webinars are an opportunity to feature leaders throughout the discipline, invite them to tell their leadership stories and share their insights. And this is also an opportunity to celebrate statisticians and data scientists who have achieved great things and who have inspired others in different ways. Now, the topic of today is leadership in communication of statistics. And to introduce it, let me start with a quote by Anne Roy, clinical psychologist and full professor at Harvard University, who wrote, "Nothing in science has any value to society if it is not communicated." So the question in today's webinar is, what is then the value of statistics, especially in a phase characterized by an increasing attention and public debate on AI? And how to communicate this value effectively to diverse audiences, including scholars from other fields, industry, policymaker, media, and the public. So today we are fortunate to have two influential leaders who will help us answer this question by sharing their unique experience, vision, and suggestion in communicating statistics. So let me start by introducing the first, Dr. Francesca Dominici. Francesca is Clarence James Gamble Professor of Biostatistics, Population, and Data Science at the Harvard T.H. Chan School of Public Health, as well as director of the Harvard Data Science Initiative at Harvard University. She's also elected fellow of the National Academy of Medicine, the IMS, ASA, and ISBA. Throughout her career, Francesca has received an impressive amount of outstanding recognition. In 2024, in particular, she was named by the Time 100 Health as one of the most influential scientists in global health in the world. And in 2022, she was also awarded the Most Seller Statistician of the Year by the Boston chapter of the American Statistical Association. So this award is given to a distinguished statistician who has made exceptional contribution to the fields of statistics and outstanding service to the statistical community. Let me conclude by saying that Francesca is also the founder and lead principal investigator for the National Studies on Air Pollution and Health Group. And their work has been covered by the New York Times, Los Angeles Times, BBC, Guardian, CNN, and NPR, among others. So thanks a lot, Francesca, for accepting the invitation. And let me also thank the second panelist, Sir David Spiegelhalter. David is Emeritus Professor of Statistics at the University of Cambridge and previously served as chair at the Winton Center for Risk and Evidence Communication. He has been also president of the Royal Statistical Society and fellow of the Royal Society. Similarly to Francesca, also David has an impressive list of recognition. He won the bronze, silver, and gold Guy medal by the Royal Statistical Society and was also knighted in 2014. Although let me say that according to his website, his proudest achievement is doing moderately well in the first series of Winter Wipeout on BBC One under the name of Professor Risk. David is author of impactful books, among others, The Art of Statistics. Quoting a comment on his book by Sir Adrian Smith, the former director of the Alan Turing Institute, H.G. Wells is frequently quoted as having said that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. That day has certainly come. This wonderful book provides a non-technical and entertaining introduction to the basic tools of statistical thinking Wells would have approved. Finally, let me conclude by saying that also David's research and contribution to science have been covered by the Financial Times, the New Yorker, Guardian, BBC, and CNN, among others. So thank you again, David, for joining this webinar. So now, after this very long introduction, let me just briefly summarize the structure of today's event. So first, each panelist will have 10 minutes to talk about their leadership journey. Then I've prepared some questions for them. And finally, time permitting, we will open it up to the audience. So I'll stop here and I will leave the floor to Francesca. Thank you again, Francesca, for accepting the invitation.
Sure. I have a few slides. Okay. I guess you can see my slide, right? So
Yes.
I'm going to be very, very brief. I just want to set the stage. First of all, Daniele, thank you so much for inviting me. And it's such an honor and privilege to have this session with Sir David Spiegelhalter, such an inspiration in terms of communicating statistics. So I am really humbled in talking about, communication statistics with David. So I just want to spend a few minutes to set the stage in terms of what I do and why, whether willingly or unwillingly, I've been very much exposed in communicating statistics in general. So first of all, in my role of leading data science at Harvard, the data science initiative at Harvard is a data science that includes data science work across all of the 12 schools at Harvard. And so a lot of my work has been in communicating the value of data science to solve really important societal problems across a wide variety of topics, from climate to sustainability to human health to cleaner energy and global prosperity. And so there is a lot of that I do in terms of the importance of why do we need data science to solve problems. The other piece of, which I know is going to be a topic of this panel, is also, not only to talk about the data science is important to solve societal problem, but data science, which is also including statistics, is really paramount in this a new AI revolution. So we need data science to solve societal problems. We also need data science in this new AI revolution. And these are just some examples of where, without real important foundation of data science and statistics, AI starts hallucinating and giving wrong information and all of that. So we will talk more about that, but I've been very much involved into the communication and the importance of ethical and responsible AI, whether we get irresponsible AI without strong foundation in data science. Now, a lot of what I do is taking massive amount of data to inform regulatory policy and to basically inform the US government about whether or not to implement policy with respect to regulating air pollution and regulating climate stressor. So it's a lot of data science and statistics to inform regulatory policy. And I want to bring just one of example that we'll talk more about that I've been really much in the center of, with many statisticians, is when we provided the first studies during the COVID pandemic, the first studies that link the relationship between exposure to air pollution to increase COVID incidents and mortality. This was still when we published the study under the Trump administration. Then we transitioned to the Biden administration, and now we are back in the Trump administration. And the reason why I want to mention this study, because this is something I'm going to come back during our panel about the importance of communicating statistics when there is a rapidly evolving situation in context of highly controversial topic with respect to what is the geopolitical situation. So we published this study, and so let you see that, at that time there was this is an headline in the Washington Post, which say a Harvard study tying coronavirus death rates to pollution is causing an uproar in Washington. And so this study actually at that time was highly controversial, highly dismissed during the Trump administration. In fact, the Trump officials said that are emphasizing that the data that we use were too raw, that our model was too rickety. But then actually the information about the study and many other studies actually led to the change in the regulation in the United States during the Trump administration, with huge benefit in public health. So basically, they changed the federal law in the United States, so the National Ambient Air Quality Standard. They make the standards more stringent, saving thousands of life with the cost exceeding the benefit by 90 to 1. That is just an example of how we have been able, through data science and rigorous science, to really clean up our air. And then, of course, now this work is becoming controversial as well now with the new administration in the context of climate change. So a lot of what I do is data science pipeline, rigorous data science and statistics to inform the government about whether or not and how to pass regulation, both for air quality, but also for the transition to a greener reality and sustainability, and to minimize the carbon footprint of what's happening under the climate change. So as I mentioned, it really led to a change of the law. And so this was in February 7, 2024. That's where all of the work in data science, including the highly controversial work during the COVID pandemic, really led to this really, I would say, very important victory in public health. Of course, all of this work, and when we talk about the impact, is by no means I do it by myself. We have a large community that is called the National Study of Pollution and Health. There are hundreds of students, faculty, postdoctoral fellows around the country that in the US, which I'm really proud that I've been enabling them to access a common data infrastructure and platform to really inform all kinds of decision about air quality and the transition to cleaner energy. The other piece, and I just want to mention and want to stay within my 10 minutes, and just talking about doing data science that is timely and communicating and controversial. The other really piece of work that I'm now doing is looking at the carbon and air pollution consequences of cryptocurrency and AI, and the importance to work very closely with really important influential journalists. So this is an article that came up in the New York Times a couple of years ago that really captured my attention. This was the real world cost of the digital race for cryptocurrency. Cryptocurrency is actually, it's exploding in the United States, has been banned in China, is now exploding in the United States. I've been getting in touch and working very closely with Gabe Dance, Pulitzer Prizer, and really an investigative journalist of the New York Times. And then, with my colleagues, we are really creating a data science pipeline to quantify the environmental cost of cryptocurrency. And so showing this is going to be published very soon, and you can imagine there is going to be a lot of press attention, including with the current administration, showing that not only we don't need cryptocurrency, but actually cryptocurrency can be bad for you because of this data center are drawing a lot of energy and a lot of dirty energy that then transform into air pollution, and air pollution travel and is affecting community in the United States that tends to be more marginalized. And so I'm concluding that in other things I'm doing that I'm very passionate about with my colleagues and led by some of the junior my colleagues is really to quantify the carbon footprint of AI. And so how do we communicate the data science pipeline and the consequences? Because what's happening is a lot of the coal-fired power plants in the United States, that is the most dirty in terms of creating energy, are still functioning to produce and to be able to provide energy to the explosion of data science, for the explosion of data center in the United States due to AI. So this is an article, in case you are interested, on MIT Technological Review that mentioned the work that we are doing on this space. So to wrap it up, a lot of communication, a lot of the work I do is really trying to communicate and inform government and stakeholder of how to make decision that is based on data science, but also dealing with often stakeholder, they have a very vested interest about what this data science result should be telling us what to do. I'm going to stop here and I want to turn it to David.
Thanks a lot, Francesca, for the presentation and also for all the work that you're doing along these very important lines. Let's move to David now.
Okay, Here I go. Right. Can you see that? Okay. Yeah,
Yes.
good. Okay, that's me. I haven't put leadership in there. I feel a bit guilty being on this webinar because I'm not a leader. You know, I've always avoided any sort of position of responsibility. It's my greatest achievement, I think, is to have done fairly well without ever being in charge of anything whatsoever. But I suppose my leadership would be maybe setting an example. And that's the extent of it. And I used to do, some people may know, I used to do sort of statistical methodology. I was working on uncertainty in AI in the 1980s, 40 years ago. We thought we solved it. Never mind. And then Bayesian methods and clinical trials, rather familiar to Francesca, and Bayesian computation. I was doing all that sort of stuff and writing papers and all that traditional things. Frankly, I was getting very bored with it, and I was really lucky in 2007 to get a philanthropically funded post by a hedge fund billionaire. I was Winton Professor for the Public Understanding of Risks. So essentially, I just moved, not immediately, but so gradually, into a communication job, a performing job. And I worked out, I actually wrote a sort of plan, what I wanted to get involved in, which was television, radio, schools talks, writing articles, writing popular books, and all that kind of standard science communication stuff. And to be honest, I've done it. I have done it, some with more success than others. So, I made TV programs that won AAAS award, Climate Change by Numbers with Hannah Fry, another TV program. It was when BBC Four were making science programs fronted by academics rather than celebrities. Sadly, it doesn't seem to be happening anymore. As Daniele mentioned, my greatest achievement was going on Wipeout in Buenos Aires, jumping over the big red balls. If we have time at the end, I could even show you how I got on. And then I ended up on anyone in the UK would know this was, in a way, the pinnacle of achievement to get on desert island discs when you say what 8, gramophone records, as they still call them, you would take to a desert island if you were stranded on it. So that was good fun. And I've written some books as Art of Statistics, which has done very well. Again, it was, that's the UK and the American version. And I'm pleased to know it's being used on courses at Bocconi University, which is great. So it's, non-technical introduction to ideas behind statistics. And my new book, plug, I mean, what's the point in appearing unless you can do a plug, Art of Uncertainty, and that's the US version coming out next month. Which is essentially, again, a sort of popular approach to probability and uncertainty. COVID illustrates the kind of work I ended up getting into a lot after I developed, before COVID, a lot of good relationships with journalists. In the UK, we have something called the Science Media Centre, which acts as a conduit between scientists and journalists. So I'd already sort of got into that world, and then COVID came along, and suddenly there was enormous demand for scientists to explain what was going on. And I had a big role. And one of the things we did with Anthony Masters, we wrote a column. 350 words were allowed in one of the major Sunday newspapers every week for a year throughout 2021. We wrote a column on statistics of COVID without really ever repeating ourselves. And the real challenge, 350 words, for a start, it's twice as difficult as 700 words. And, with of course, no formulae, no graphs, actually not many numbers, and so on, no jargon. So it's a real challenge. Now, I should say Anthony Masters, the reason that I was working with him, he wasn't, he was a statistician in a bank, but he had joined the course we have at the Royal Statistical Society of statistical ambassadors, where we've taken intake of 8 to 10 younger career young people and give them some media training and form a sort of group and encourage people to engage with the public, whether that's giving schools talks, doing media stuff, helping journalists, all sorts of different ways. And that's what Anthony did. And now we ended up writing a book together, which is rather good, I think. So that was through our Royal Statistical Society Statistical Ambassador course, which is there to get statisticians out into the public gaze. Now, this is, we experienced this everyone had this in their own country. We had that's our one of the briefings that used to be happening every day in the COVID. There's, out of those 3 people, I have the deepest respect for 2 of them and utter contempt for 1 of them. And you can have to guess who that might be. But I'd just like to show you the sort of thing I had to get into when this is the main politics program in the UK, which was on Sunday morning. And I was complaining about the statistics and how it was treated in those briefings. So I'll just show you, it's only 1 minute, so I'll just show you this particular little rant I did.
You're now very familiar with these daily press briefings. How well are they working, do you think?
Well, I watched yesterday's, and frankly, I found it completely embarrassing. We get told lots of big numbers, imprecise numbers of tests being done, 96,878. Well, that's not how many were done yesterday. That includes people that were posted out, tests that were posted out. We're told 31,587 people have died. No, they haven't. It's far more than that. So I think this is, actually not trustworthy communication of statistics. And it's such a missed opportunity. There's the public out there who are broadly very supportive of the measures. They're hungry for details, for facts, for genuine information. And yet they get fed this, what I call number theatre, which seems to be coordinated really much more by, a number 10 communications team, rather than genuinely trying to inform people about what's going on. I just wish that the data was being brought together and presented by people who really knew its strengths and limitations and could treat the audience with some respect. I mean, that went down quite, that little clip got 1.7 million views on YouTube, and the phrase number theatre became quite popular. But of course, most of the queries I got was, why have I got using a pen with 2 pink rabbit ears on it? And what's that thing behind my head? What's that good doing in the lampshade behind my head? So that's the sort of thing you got to expect from if you get involved with communication, and a certain amount of abuse. I won't talk about that in detail. Somebody might want to ask about that, but that's one of the things you have to put up with.
They're now very familiar.
Oh, hang on. Yeah. Okay. So one of the other things we did completely behind the scenes was in COVID, but I think it was a really good piece of communication, was working with the Deputy Chief Medical Officer at the risks and benefits of the AstraZeneca vaccine, which was being linked with serious blood clots in people's heads. And this was John Aston and Alex Freeman. And we got the data, analyzed the data, did a Poisson regression, everything, prepared the graphics in 48 hours of intense work. And it just went straight onto the BBC, this graphic we produced, which tried to show that for 100,000 people with low exposure risk, which is what was the case at the time, how on the left you had the potential benefits of the vaccine in terms of intensive care admissions prevented, and how there was an enormous age gradient, with it being quite high for older people but almost negligible for young people. But in terms of the serious harms, when we fitted the Poisson regression, we got an increase of risk for younger people. So by the time you get to young, look at the harm benefit ratio. And so that was a very visual way of showing why the vaccine was no longer going to be given to younger people. And this is a really quite complex graph with many different factors being taken place. But the guy communicating it was extremely good at it, and it went down really well. Everyone accepted it. It got reproduced. everyone copied it. And for us, I think that was a real achievement in statistical communication, which was very effective indeed. Okay, the other aspect I've been involved in a lot is public inquiry, scandals, and which require, and where the legal team gets in a group of statisticians to help with the analysis. So I did 20 years, 25 years ago, worked on the Bristol public inquiry with a whole lot of babies died from botched heart surgery. Look, that's the group of statisticians they had. First of all, they're all men. And secondly, it looks like something out of Reservoir Dogs. I mean, really, what a suspicious looking group of people. I wouldn't trust them an inch. But we all worked on it. And that was my first, I started getting appearance on television. And then the Shipman inquiry to our mass murderer who murdered at least 250 people, trying to work out using statistical methods, could he have been identified earlier? Recently done the infected blood inquiry with other people you might recognize, looking into the numbers of people who had been infected and then died because of being given infected blood, HIV and hepatitis. during the 70s and 80s, and we estimated about 30,000 people had been infected and 3,000 had died because of it. And just recently, you may have heard about the nurse Lucy Letby, who's been convicted of murdering a series of 7 babies. I've appeared at the public inquiry into that case, and they're very interesting from a communication point of view. And it's a phrase I really like, is mandated science. It's where, and Francesca would know about this, where you're essentially asked to try to answer, you're asked to try to answer a question, regardless of how good the evidence is, in where you have to try to answer. And sometimes you have to be prepared, we can't answer the question. And that I found very liberating, when we've got such low confidence in the available. We were asked how many people had died infected with hepatitis B from infected blood, and we just refused to answer it. So no, the evidence is just too poor. But from a communication point of view, all of this has to be done in a way that's comprehensible to the lawyers, to the public, to the journalists, and from a very personal point of view, when you are giving evidence, in all those inquiries, the families of the victims are sitting in the front row watching you, and holding up pictures of the members of their families who have died. So it's it's quite a challenge to do that, and I could talk about that later. So just to finish off, 2021, during COVID, I wrote a guide with Kevin McConway in Significance on communicating for media engagement for statisticians, really taking into account our experience and trying to tell people the lessons that we've learned. 2 of the lessons were: avoid just talking to someone in a lengthy interview when they're only going to pick out 1 or 2 sentences, because almost certainly they'll pick out the sentences that you didn't mean to say, the slightly casual things you might have said at the beginning or the end. Never do that. And the other thing is, things will go wrong. Now, I thought I'd learned that lesson. I fell for it 3 weeks ago again. I did an interview for a TV news, one of the main bulletins, national news, and so, we're doing an interview, and we talked about it, and I should know that they're only going to use a segment, a 10-second segment, and he picked out the sentence which did not represent what I actually thought. I complained bitterly and actually cancelled it from the recording, etc., etc. But it just shows what you fall for. And now I know, if I ever going to do a TV segment again, I'll just prepare my 2 sentences, say them, and then shut up and refuse to say anything else. So you've got to take control of the situation. I've also actually started writing, partly based on my new book, articles myself, which I quite like doing. So this was an article in just last 6 weeks ago in The Guardian, a major national newspaper. It was in the self and well-being, life and style section of the magazine. For heaven's sakes, what's a statistician doing writing in that? But it was quite fun to do it, and it seemed to go down quite well. So just some conclusions is that it's been fantastic to have a career change, to focus on communication. And also, I have worked with a team of psychologists and communication professionals studying communication scientifically, doing randomized trials of different formats, both visual and verbal, and seeing how that affects the trust in the source, for example, which is incredibly valuable. But it takes time and effort and practice to do it. And it's not for everybody at all. A lot of statisticians would, I think, I have greatest respect for people who would rather be in the background doing analytic work, doing the analyses, maybe writing clearly, but not wanting to actually stick their head up. And that's absolutely fine. But everyone should have the opportunity to try. And I do feel that communication should be an integral part of statistics training. Whether it's visualization or writing blogs or articles or popular communicating it. So people should learn to communicate at different levels, not just at a technical level. Again, not everybody wants to do this, but some people do, and some people get very good at it. And I would say specialist media training can be very useful. And so I'll stop there. If somebody does want to know how I got on at Winter Wipeout, I could show them later if there is demand. Okay, thank you very much indeed.
Thanks a lot, David, for the presentation. At the beginning, you said you don't like to be called a leader, but from the presentation, it's clear that you deserve to be called a leader. Okay, so now it's time for the moderated Q&A question I prepared. In the meanwhile, let me invite the audience to start adding your own question to the Q&A function. So time permitting, I will also ask some of these questions at the end. So let me start with the first question. It's quite long, but to me is one of the most important, because before discussing how to communicate statistic, I think it's important to ask you, what is statistic for you, and what should we communicate as a community? And in particular, to articulate my question, let me take a quote from the preface of the book Dicing with Death by Stephen Sand, that I actually remember as the quote which truly inspired me when I was a first-year university student in statistics in Padova. It says, "Statistics is a wonderful discipline. It has it all: mathematics and philosophy, analysis and empiricism, as well as applicability, relevance, and the fascination of data. It demands clear thinking, good judgment, and flair. Statisticians are engaged in an exhausting but exhilarating struggle with the biggest challenge that philosophy makes to science. How do we translate information into knowledge?" So after this long preamble, what are the core aspects that make statistics so unique and central as a discipline that we as a community should insist in communicating? And to be a bit more provocative and concrete, with a renewed interest in AI, are these aspects still so essential and relevant? Or is statistics nowadays, at least in the public perception, say beyond our community, just a small fraction of a much broader wave, which has other fields that are often more effective in and inclined to communication than us? Let's start with Francesca.
Well, thank you, Daniele. Very long question. So just few thoughts to be kind of synthetic and provide some sound bites. I mean, I think, first of all, I spent my entire life doing statistics, has been love at first sight. I think that because of the explosion of data and technology in the last probably now 10 years, I think it's hard to talk only about statistics without talking about data science and now AI. And I can just say my viewpoint, and of course there are people that might think differently, but how I think now is always that data science is the most general term, because I think when I'm thinking about data science, I also think about data processing, data harmonization, data linkage, until I get the data set, that then I start applying some statistical modeling. And I do think that these days, the early steps of a data science pipeline are as important as the later step in terms of figuring out, the best statistical model to analyze the data, because without good data, everything else goes away. And so I really start thinking more and more that good foundation of data science is essential, not only to do good statistics, but also to do good AI. And so in my mind, I see data science at the foundation of the most general term, and statistics sitting on top, and AI sitting on top. I think that statistics and biostatistics to me is all about interpretability. AI is not about interpretability. Statistics is about making some clear assumption and really thinking about the sampling process and the uncertainty. AI is not about the assumption. AI is designed to not rely on any assumption, especially now with generative AI, where we are trying to mimic our reasoning. Data science is the good foundation for both. Without good data science, you get bad statistical analysis and very bad AI. I think that in the communication, I could not stress enough to always think back about what are the foundation of data science and statistics. And so what I'm thinking about is just some few key principles: the quality and the representativeness of the data. They give a sense of how much subjectivity and assumption we have made to get to some conclusion, the interpretability of what we are doing, and the quantification of uncertainty.
Thanks a lot, Francesca. David, do you want to add something?
Yeah, no, I would agree with all of that. I just think statistics is the most fantastic discipline because of what you asked in your question and what Francesca's been describing, because it just covers so much. We've learned, a lot of technical stuff, and yet when we're communicating, we have to simplify it down, but not too much. And, I often think, we mustn't be wrong, but it doesn't mean we have to be absolutely pedantically correct about absolutely everything. And that judgment is extremely important when we're thinking about communication, because we do tend to be fairly pedantic people. We want things to be defined properly. We want to know what things mean. And, we want the evidence, we want the data. We're pretty nerdy. But when we're out there communicating, we've got to try to shed some of that. And I've tried to answer a couple of the questions in the Q&A, which and I haven't done it very successfully, but from Murali Haran, which are very relevant because they're all to do with what degree of complexity do you communicate? And so they asked about the AstraZeneca slide we used, in which we didn't include uncertainty because, you could blur the blobs, it would make it too complicated. We didn't include more context. For example, I know other harms and benefits of the vaccines, which we could have, but we cut them out, trying to reduce it to the absolute bare minimum. But we had to include age. Age was so massively important, and the prevalence of COVID, that we just you can't communicate the average risk or the average benefit. It's pointless. It has to be. So it's working out what actually are the absolute core things and focusing on those. And similarly, asked me about, doing a quicker analysis. What about domain scientists? One of the things I really learned in COVID was to learn. Not my job. I say, a lot of, and I've learned to use it again and again now. I used to think that when I was asked a question, I had to answer it. I said, no, absolutely no. So you have to make a very quick judgment about whether it is in your area of expertise. And if it isn't, just say, no, not my job. You'll have to ask a virologist, an epidemiologist, a modeler, a policy person, and things like that, because people always want to stretch. They always want to pull you into some controversy. Who's to blame? What should we do? Etc. etc. And I say, that's not my job. I'm explaining the numbers. Sorry, I'm going to stick to that. And I learned how to do that, and it took a long time, I think, to learn to do it in a light way. I'm not being defensive. I'm not being dismissive. I'm trying not to be pompous. I do it with a laugh and say, no, you must be joking. I don't know anything about that. You'll have to ask somebody else. And next question, please. And I've done that live in front of huge audiences, and it got a huge laugh and people really appreciated it, just refusing to answer the question. So I think this does come down to what statistics is, in that it's difficult and complex and uses a huge amount of experience and background knowledge, none of which should be visible when you're communicating. It should be implicit. You shouldn't be showing off your knowledge. You can't use any jargon. You cannot use any mathematics. And that, I think, is a bit of a learned skill. We train people, we try to train statisticians to do that. And, because you can't use words like p-value, statistical significance, confidence interval. No, complete or banned totally these phrases. So it's really healthy trying to do it without using these phrases.
Thanks a lot, David. So what you have been saying, and Francesca as well, bring me actually perfectly to the second question, which is, to whom shall we communicate statistics and now? So taking a quote from your book, David, you say the first rule of communication is to shut up and listen, so that you get to know about the audience for your communication. We have to understand their inevitable limitation and misunderstanding. So statistics, has a particularly wide range of audiences due to its broad relevance. So my question for you is, let's say, what is your minimax optimal solution in communicating statistics? So particular, how do you minimize the difficulties when it arise, that arise when engaging with the most challenging audiences? So David, maybe you can start now.
Yeah, I think of people I know, who are not statisticians, not scientists, but are interested, and think, if I was sitting around at a dinner table trying to explain this to somebody, maybe you got an aunt, not your parent, not your mother or your father, they love you too much, but maybe an uncle or an aunt who's maybe a bit skeptical as well, and you got to try to explain it, and you're talking to them. And that's the same. I find you need to listen. You need to try to have an idea of what people's misunderstandings are. That's the listening aspect. You know, what do people bring to this? And of course, that does vary hugely. I know some people will be extremely skeptical, some people will be very positive, and you know, whatever you say. You have to understand that variation, I think, in people's receptivity to what you're saying, and try to reach them. And the crucial thing, which we've shown experimentally, is to demonstrate trustworthiness by being balanced, not to try to manipulate their emotions one way or another by making them frightened or reassured or something like that, not to weaponize the numbers, not to politicize the numbers, but really try to, because people can sense it. They can sense it very quickly if you're trying to manipulate them and trying to persuade them of something. But if you're actually genuinely trying to inform them and empower them to make better decisions, people can sniff that very quickly, and they really appreciate it. And it increases the trust in the people who are most skeptical, which we've shown.
Yeah.
Thanks, David. Francesca?
Yeah, so to just add, I think first of all, communicating statistics to general audience, especially if it's about highly controversial topic, whether for political reason or in the context of crime, it is extremely hard, and I don't think you cannot treat it casually, right? And I feel like, you know, as David, I made a lot of mistakes, and I know we're going to talk about mistakes, because even often what happened, and maybe I'm very candid about it, even if we know what is the right thing to do, there is, I think, an element of narcissism that comes up, because, you know, these journalists call you and they say, oh, you are the expert. And you feel like, oh, I am the expert. Let me tell you, right?
Yeah.
And so then you fell into this trap. It's a trap, right? And so I think in terms of what I do is, because it's so hard, I literally do the homework. I mean, I write down what is the result, how I'm interpreting, how I'm going to say it, how I'm going to communicate the uncertainty. And I think, you know, really consistently what David is saying, you first is a lot of work. You take it seriously. You try to stick with the script, but it's hard because they start, you know, they are able to push some buttons, and they give you this trap where they make you feel that you're more expert on things that you don't know anything about it. And that's where you feel the trap, right, David?
That is so true, because they flatter you, and you got to become immune to flattery. They say, oh, you're so wonderful. You know, they always say, lovely, oh, what a wonderful job you're doing. And you just got to harden yourself to that flattery. But I'd like to again emphasize the idea of a script. I really prepare hard, even for a short interview, and get everything ready. Get it, if I'm doing it on television, on the laptop underneath the green dot, I've got it written out so I can see what I don't read it, but you prepare the phrases you're going to use, and the crucial thing is then stick to that and don't allow yourself to get pulled off. And it's so easy to be put, and so that's why I said you have to learn how to not allow you both to recognize when it's happening, and then get things back on course. And it's something you can learn. Yeah.
Yeah. The other thing, just a general advice, is depending on the reporter, as soon as you start having the interview, I think it's really important that you learn the rule of the game. So, for example, are they recording you? Are they going to be willing to share the quotes with you so then you can edit it? So I think first, this is a general advice to everybody, just figuring out what they're doing and what you will be allowed to do after the interview. And again, also be careful, because even if they say, yes, of course, we'll share the quotes with you, that not always happen as well, right? But I think to understand with who you're dealing with, what are the rules of the engagement before you open your mouth.
Absolutely. And the first thing, of course, is to find out if anything's on the record or off the record. And my favorite way now to operate with journalists is to say, okay, all off the record, and then we'll agree some quotes. So you can have a chat, you can be as rude as you want to people because they have to stick to their off the record. And then you say, okay, what do you want, what do you want to lift out of what we've discussed? And then I provide some quotes by email, agreed. So I'm prepared. And those are the only quotes you can use. And that works. People say that works. It works because they get both the off the record chat and find out more about it. At the same time, they get some usable quotes. So that's my standard way of working now with journalists. Yeah.
Thanks.
See, Daniele, very briefly, I see there is a question about why, there is a question by Peter about the script and said, how do you respond to requests from journalists? Very timely. I mean, the other thing which just to keep in mind is often a journalist email you before. And so ask as much, always ask by default, can you email me your question before the interview? So even if they really wanted to interview, to really ask them, can you email me the key question that you want to ask? So then when you go to the interview, you have the script prepare, and you know with who you're dealing with.
Thanks. So let's stay with the media. I mean, we have criticized them a bit, and we tend to criticize them for pure communication of statistics sometimes. But my question is, are we really that perfect as statisticians? So what is the most common mistake we make as statistical scientists when it comes to communicate statistics to you?
First of all, I know this, although I completely agree with David that during the COVID, oh my God, it was just a total mess. It's no question about it. And I think, the media were not prepared. We statisticians were not prepared. Having said so, I did notice an improvement in interacting with the media and the ability of the media to communicate statistics results. It's by not perfect, but I'm seeing it's better. Most of my interaction are with the New York Times and the Guardian, and I found them really careful. And also, I think they're really improving into their data visualization and doing it much, much better. We statisticians, we are absolutely not perfect, highly imperfect. And I'm giving you an example of a huge mistake I made, which I got in so much trouble, which goes back to be prepared. And I was prepared. I have my script. And this, again, was the COVID, was when we published the study about the fact that air pollution, exposure to air pollution was increasing the risk of mortality for COVID. And don't ask me how. I didn't sleep for 3 days. We were posting new results. We were talking to the media. And instead of reporting the result by saying for 10 units increase in exposure to fine particulate matter, the mortality risk increased by 10%. Instead of saying that, which was the right answer, I said the increased risk for COVID is tenfold. Okay, that was a huge mistake. Right. So she put it on the New York Times, and I read that and I was like, OMG. And so I call her and she started yelling at me, right? So to tell you, it's hard because you're sleep deprived, you have a script. And that was one of the things where also you don't want to have an interview if you are not rested and you are in the middle of a panic, right? So that was a huge, huge mistake, which I made. I could not believe it, but I did it. So.
Okay. Well, I'd say that for statisticians, I think, as many people have mentioned, the worst problem, I think, is their pedantry of, wanting to do too much detail, using jargon and so on, and not getting to the core of the matter. And a number of questions about p-values come up, because that is a really difficult thing. And I'd never use the phrase p-value. And what do you use instead? I mean, if I'm being loose, I'd say, which of course, isn't correct. I'd say, well, it's unlikely to be due to chance, but that's of course giving the, putting the probability on the wrong thing. If I'm more careful, and if I've got a script, I will be more careful. And they say, well, if it was only chance operating, it's unlikely we'd have observed something so big. And I think it's okay to use a phrase rather than a single word. You go when you're talking, you've got time. And it's much clearer to give a longer explanation rather than, I think, trying to summarize everything by single words. And so I do think, and that we got to practice, and you get it wrong. and you always get it wrong. But I think that's the crucial main problem that statisticians have. Because I think it depends who you talk to. As somebody asked about, because if you're communicating to data scientists, it's a completely different issue. You can use a totally different language. And so a lot of it, I think, is looking at what good journalists do and try to copy how they do it, how they do their communication, because good journalists can get some very complicated stuff over in simple phrases and tell a good story. And a lot of this is also learning about storytelling, about trustworthy narratives, how to construct the story. I often put myself into the story. I'm quite happy to do that, to talk about how it's affected me or something like that, which is, not everybody would be happy doing it. I'm happy doing it, and that helps, I think.
Thanks. So let me be a bit thought-provoking now. So, so far we have been discussing about all these interesting questions about effective communication of statistics, but out there now there are large language models to whom I could ask to communicate effectively for me in different forms with much less effort. So, I was interested to understand, how do you see the impact of these new systems in communication, and in particular, whether you think they will augment and enhance our potential in communication, or just make us, let's say, lazier, less creative, and less diverse in the way in which we communicate statistics and science more broadly.
Who's
David?
first? Okay, I'm first. Well, I use them. I use Claude. I tend to, as I like it. So I use it for summarizing information. I also use it you can use it to critique papers, which it can do rather well. Something I've spent decades learning how to do, which is a bit infuriating sometimes. You always have to check what it says, but you can also use it to do initial stories. It's so bland what it actually says. It always has to be rewritten to make it more personal, more engaging. Use your own language, use your own style. But I think they can be extremely useful. Apart from coding and things like that, of course. So I think that it's going to grow and grow. Automated data analysis will grow and grow. And we just have to always make sure that there's a human filter, a skilled human filter between them and anything that goes out. So they're only being used as a preliminary sort of screen or a preliminary suggestion or whatever.
Yeah. And of course, I think there is no question they're very, very powerful tool. I also rely on, I think that, so for example, I like to use AI tools that cite the source. So for example, Perplexity AI, when they give you a summary, at least it's cite where the information comes from. And that goes back to the data science foundation of AI, in terms of that I think that there is no question that AI is revolutionizing everything that we do, and generative AI in particular. The human filter comes in two ways, right? One is to figure out what the information they're relying on it. And so in the same, making sure that it's trustworthy. And from a statistician viewpoint, what is a little scary with generative AI is that you don't have the ground truth, right? It's generating new content. And so that's why I think I feel like we are not going to be without jobs. So let's put it that way, because I think the human filter is essential, and it will continue to be that way.
The quote I like is when was asked, a radiologist who was reading X-rays was asked, is AI going to replace radiologists? He said, no, but it might replace radiologists who don't use AI.
That's right.
And I wonder whether the same might apply to statisticians in the future.
I think so. Yeah.
Okay, thank you. So, time for the last question, also trying to summarize also some from the Q&A. And I would just ask you a wish that you have for the future of statistics, and more generally, 2 suggestions for those statisticians who would like to contribute to its dissemination, not just within academia, but also beyond. And also, how do we position ourselves with this trend of AI?
Yeah, so maybe I can start very quickly. I do think that what is missing right now, apart from some exceptional circumstances like the center that David had the privilege of leading. But I think that if there are statisticians at different stages of careers from which they have a passion of interest of being involved in communication and statistics, there is not a simple way to get involved and be properly trained. And so I do think, and with and without the help of AI, and so I think, I do the regular training in my own lab in terms that, there are some rules I use and to making sure they're at least fluent in speaking with the media. So my wish would be that in terms of the statistical association, whatever is the US, Europe, or worldwide, we start really thinking about, providing easier opportunity to get engaged in the I would say in developing the leadership and the skill of communicating statistics to the general public for whoever is interested.
Yeah, I completely agree. I mean, I feel we're a very honorable profession. We really are. Our hearts are in the right place. We want to see things done properly. We tend not to have very strong agendas, political agendas, or whatever. We just want to see, things done properly, evidence being used appropriately. And I think that's a deeply honorable, and I think we deserve a higher profile in society, and not telling people what to do or telling people what they should think, but just trying to inform people, empowering people to make better decisions. I feel that very strongly, and I think that as I said when I was talking, that I think many statisticians, are very interested in doing that, and as Francesca said, there should be the opportunity for their development through their employer or through the statistical associations. I feel that very strongly, and because I think it's for the benefit of all society that we don't just sit in the background being nerdy and clever, but actually we use our insights to improve the general level of understanding, and try to counter in some way the appalling polarization in society to do with arguments that often concern evidence and numbers. And so in COVID, I spent I was in the middle, being attacked from both sides perpetually, but there was a group of us who were really trying to hold the fort in the middle, just trying to be sensible and talking about what was going on, rather than turning into policy advocates. And I think that is actually, it suits my personality, but I think that's actually what we should be trying to do.
Thanks a lot,
Daniela. I have had a certain number of requests for my performance in Winter Whiteoats.
We have 1 minute to show it if you want.
Oh, can I? Well, do it. Is it really going to stop at an hour exactly?
I don't think so.
No. Okay. Well, then I'll show it. Do your finishing bit. I'll show it at the end, and people can leave if they don't want to watch me falling in the water.
Okay, so unfortunately, we have to close here. This is a 1 hour webinar, but let me say that I was enjoying so much this conversation that I would have continued for 1 hour or even more. Anyway, even if we didn't manage to go through all the questions of the audience, I hope that this webinar has contributed to raise awareness on how important it is in communicating statistics. Especially nowadays. And I'm extremely grateful to Francesca and David for walking us through this short journey. Let me also thank the whole organizing committee of the COPSS-NISS Leadership Webinar Series. Again, not only for the work in the organization, but also for giving me this wonderful opportunity to have the chance to organize and moderate the webinar with Francesca and David. So thank you so much for listening. If you found this conversation to be helpful, please share the recording with your colleagues and stay tuned for more events like this one from the COPSS-NISS Leadership Webinar Series. So thank you again.
Thank you. Bye-bye.
Thanks very much. It was great.
Bye-bye.
Okay, can I try sharing my screen? Come on, let me try and see if it works. So let me try. So the point is, if anyone's watching, that this is this obstacle course in Buenos Aires that you go to, and I'd done the statistical analysis of the times in the qualifier round, because you have to, the first 12 go through, and out of the 20 that compete, and so it fitted a low S regression to the times of the 12th fastest that needed to qualify to go through the second round. We worked out it was 3 minutes. And so I realized I had to, I trained very hard to do 3 minutes. So,
Professor David Spiegelhalter, OBE, Ali the Penguin King, and Guinea Pig Men.
so I think it just shows that what the benefit of studying statistics, what the stupid situations it can get you into. Thank you very much indeed.
Thank you again, David and Francesca. It has been an honor. Thank you.
Bye-bye. Bye-bye.
Bye. Thanks so much. Great session. Francesca, thank you so much. It's lovely to talk to you.
Likewise. Bye-bye.
Thank you again.
Bye.
Yeah.